To start out section 8.2, we're going to talk about some key terms and concepts. So grab your notes and fill these in as we go along. So we are going to be looking at this picture over here a lot. And we're actually going to be building a unit circle that we will use throughout the rest of this course, or the rest of this section anyway, and chapter. So let me just kind of point out the pieces of it. It's basic quadrant graph. It has the x-axis and the y-axis. Notice that there's 4 quadrants. We always name the quadrant counterclockwise, starting at the positive. So this would be 1, 2, 3, 4. So we always start out at x, and we call that the beginning point, or the initial side. So the initial side of any angle that we put on this, we will always place it so that the beginning of the angle is here, and then the terminal side is wherever the angle ends up. So initial side always goes on the x positive part of the axis, and we always move, if we move counterclockwise, we're going positive. So if we went from this initial side over to this terminal side, it's about 150 degrees. If we go clockwise, then it's going to be a negative angle. So from this initial side to this terminal side clockwise, it would be negative 210. So standard position is when the vertex of the angle is at the origin and the initial side is on the positive x-axis. The initial side is the side of starting. So if you're looking at the angle, we call that the start side. The terminal side is what we call the end side. Positive angles go counterclockwise. Negative angles go clockwise. Quadrantal angles are the angles that are on the axes. So negative 360 would be right here. Negative 270 would be 3/4 the way around, so right here. Negative 180 would be right here. Negative 90. 0 is if there's just no angle at all. And then 90 degrees would be going this way, so it'd go from the initial side here up to here, 90 degrees, 180, 270, and 360, and so on. So if you have an angle that's bigger than 360, that means that it goes around more than one time. So you could figure out like 720, positive 720 would be all the way around 360 degrees 2 times. So that would be 2 revolutions of the angle. So let's have some practice drawing angles in standard position. 200 degrees, the initial side, and I'm going to get this a color so I can. So if the initial side is right here, 200 degrees, well there's 90, 180, so about 20 more degrees from there. So it would go from there to there, that would be approximately 200 degrees. Negative 200 degrees would be going the opposite direction. So we still start our initial side on the x-positive axis, only this time we're going around this way, so about right there. That we're 90, 180, 200 degrees. 470 then, so we draw our initial side first, and then let's just count. So 90, 180, 270, 360. 360 plus 90 more would be 450. So then another 20 from that. So it would go all the way around and then over here. So you have to show that it is going all the way around and then some to 470, about right there. Negative 455, well the initial side is right here. All the way around would be 360, and then I have to add at 95. So let's see, I would grab a calculator and go 455 minus 260 is 95. So I've got to go 95 more degrees. So I go another 90 degrees over and then just a little bit more. So it's about 95 beyond the 360. So that would be a negative 455 degrees. Coterminal angles have the same initial and terminal side. So if we have this angle that starts at the x positive and goes counterclockwise, so it's positive 230 degrees, and we also have this angle that starts at the x positive and goes counterclockwise, negative 130, they basically build the same angle. So 230 degrees positive and negative 130 degrees, those are called coterminal angles. And you could also have them both be positive. So if you had 230 all the way over here, 230 degrees, or if you did all the way around plus another 230, 230 and 590 angles are coterminal. So if I have to find the coterminal angle for a theta, such that it's between negative 360 and positive 360. So one possible thing, I'm just going to draw a picture so we know what we're looking at. So positive 25 degrees would be approximately this angle going from here to here. So if I want to have a coterminal angle where it's between negative 360 and 360, I don't want to go around and then some, because then it would be greater than 360. So I'm going to look for the negative angle over here. And one way to do that is it's just 360 minus 25, and then it's negative. So 360 minus 25 is 335 degrees, negative. Negative 335 degrees is the same thing as positive 25 degrees. Those are coterminal angles. Also, negative 27, if I think of it like this and draw a picture so we know what it looks like here, negative 27 would be somewhere over in this area here, going this way. So if I try to find a positive one around to there, it's whatever 360 is minus the 27. So 360 minus 27 is 333 degrees. Number 6, find a positive and negative coterminal angle for each given angle. So 420, if I drew a picture and look at what we have here, 420 is all the way around once, so that'd be 360, plus another 60, so about 2/3 of the way up. Sorry, picture's really bad. Hopefully you understand what that is. So one positive one would be just to have 60, just that little piece of it. So minus the 360 there. Another, a negative one is if we think if we're going around this way, it's 360 minus the 60, so it'd be negative 300. So there's a positive coterminal angle and a negative coterminal angle. Number 7, so number 7, negative 77 is an angle that goes about down to there. So we could think of a negative, make it more negative, is if we continue around and go around once more. So we have negative 77 plus another 360. That would be negative 437. Or if we're thinking in the positive direction, it'd be 360 minus the 77. 283. So two angles that are coterminal. This one's negative, this one's positive. And number 8, pull this one up there a little bit. Number 8, negative 480 degrees. Again, I like to draw a picture because that just doesn't make sense in my brain. So negative 480 would be negative 360 plus another 120. So there's another 90 and add another 30 to that. So it would be right there. So one possible negative answer would be to go from the x-axis over here, which would be the 120. So just negative 120. Or if we add 360 to 480 negative, we get the negative 120. A positive number would be 360 minus the 220. So a positive angle would be 240. Because 240 plus 120 is 360. The next term that you need to know is a reference angle. And a reference angle is the positive and acute angle formed by the terminal side and the x-axis. So no matter where the angle is in the quadrant, you always go from the quadrant or from the terminal side down to the axis. So, like for example, this one, it's in the second quadrant over here. So we're going to use this as our reference angle. So the reference angle goes from here to here, and that would be our reference. Now, if the angle is over here, we would go to this x-axis. If it's down here in quadrant 4, we would go to the x-positive axis. And if it was down here in quadrant 3, we'd go to the x-negative axis. So what does that mean? What does that look like? Let's look at the examples. So find the reference angle for each angle. So if I have the angle 24 degrees, which is going to be over here somewhere. So 24 degrees goes from the x-positive axis up to the angle. So it's just going to be 24 degrees. It's going to be the same. So the reference angle might be the same, it might be different. For this one, it's going to be the same because if you go from the angle down to the x-axis, it's the x-positive one, so we just keep that same angle. Next, number 10, because it's 94 degrees, which is over here in quadrant number 2, this time we're going to use this reference angle right here. So the angle that is made with the x-axis and the angle, it's going to be closer to the x-negative than it would be to the x-positive. So we're going to use that angle right there, which is 4 degrees smaller than 90 degrees. So 90 minus 4 for 86 degrees. Oops, that's the degree sign. Example, let the given point be on the terminal side of theta in standard position. So that just means that 2, -3 is on the terminal side. So here's the initial side. So that means the angle goes all the way around to here. Find the exact values of sine, cosine, tangent, secant, cosecant, and cotangent of theta. So we're going to look at this right triangle that is created with that point on the terminal side. And I'm going to really quickly fill in all the details of this triangle. So it's 2 units this way and 3 units this way. And then the length of the hypotenuse would then be, we use the Pythagorean theorem, so you got 2 squared plus 3 squared is 13. Take the square root of that, and it's the square root of 13.